Okay, let's talk about question 12. This is a question that refers to normal distribution. And also in question 13, we're looking at a GPA, the data on GPA, and it's also normally distributed. So whenever the question says it's normally distributed, we know that distribution of the data, it follows a bell curve, and the center is at the mean, and standard deviation is also usually given by the question. No matter what is the actual question's mean or standard deviation, we can always convert it to a standard normal distribution. Standard normal distribution always center at 0, and that data is called z. So your actual question, the data value is the x value, but we're using the question data converted to a z, where z is called the standard score, and z is calculated by data minus the mean divided by the standard deviation. And z always follow the standard normal distribution table. Sometimes I call that the z table. And I have the z table with me today. And the z table I'm using is called the cumulative distribution table. It provided a lot of information. These are all percentage, probability, proportion. These are all the p-values. They're all to the left of any given z. So you have to calculate z first, and then you use a table to find out. The table gives you what's on the left side of that z. If you need to find out the right side of the z, you have to do 1 minus p, 1 minus the data value from the table. Now, for example, question 12, we have the mean is 2,500, standard deviation is 60. So that is saying mean is 2,500 and standard deviation is 60. And they're normally distributed. We want to find out what's the probability, the time, the lifetime for the computer circuit board, which is our data value. What's the probability the data value can last at most 2,560? So at most means that the 2,560 is a upper bound. At most means less than. So our data is less than or equal to 2,560. This is what we're trying to calculate. And that means that we are trying to find out the left side percentage of the data value, 2,560. And this is a x. See, different from this is an x. And we know the center that is at 2,500. So we're looking for a percentage that's probably more than 50. And first we have to find out what's the standard score for this x. This is the x. So let's calculate z. Z is equal to 2,560. Z is equal to x minus the mean. The mean is 2,500. This has to be divided by the standard deviation. That's the 60. All right, and we calculate that, and that we get z equal to 1. And you can see from the table, your z value is all on the margin. This is z, and z equal to 1. The first two decimal here, last decimal there. So then our z has to have 2 decimal places. So 1.0 is what you're looking at. At the vertical margin, we find 1.0, and then the last digit provided this is the last digit, so 2.00. That the percentage is 0.8413. So the left side percentage, using the table, the left side percentage is equal to 0.8413. So we know that the answer we're looking for the left side, and the table gave us the left side. So this is our answer. On the other hand, if you are looking for a percentage that x is more than 2560, that's going to be 1 minus 0.8413. That is going to be the percentage here because it's more than. In that case, you're going to get 0.1587. Well, that will be a different question, just so to speak. If you have a different question, this is how you do the calculation. Number 3 says, we're talking about college student GPA. They're normally distributed. Then let me mark it out. This is 12, and let's talk about 13. In this question, we got a different mean. The mean is 2.5, and the standard deviation is 0.5. Okay, now we want to find out what would be the minimum GPA to be in the kappa, beta, kappa, which require the top 1%. Top 1%. So in this question, we have the percentage. In fact, it says it's top 1%. So this percentage is 0.01. That's top 1%. Whenever it says top 1% or bottom 1%, so if you are looking for bottom percentage, the graph look like this is the bottom 10%. All right, that's a different kind of equation than you're looking for this boundary. But it says the top 1%, which means the right side percentage is 1% and left side is 99%. So really in this question, the left percentage is 0.99. And now we gotta find the boundary. We're trying to find the x here, but you can't find the x without finding the z. So given this percentage, we're gonna look in this table, and you're gonna have to remember the table. These are all the percentages. This is a z. Right now, we don't know the z. We know the percentage. So we're gonna look for the closest percentage to the 99%, which one is closer to the 99? 90. This is closer to 99. That's 2.33. So the z is 2.33, and we calculate the x. That is. Abby, come get the baby. The x is equal to mu plus z times standard deviation. So this is, z give us how many standard deviation above or below the mean. When z equal to 2.33, which means it's 2.33 standard deviation more than the mean. So we're going to take the mean, that's the 2.5, and 2.5 plus the 2.33 times standard deviation, that's the 0.5. Okay, and we calculate that. That's providing our data for the data boundary for that top 1%. So you have to be higher than this value to be in this this organization. Let's do the calculation. 2.33 times 0.5. That is this. All right, and then we're going to add that to the 2.5, which is 3.765. No, 3.665. Okay. You can certainly double check that with your calculator. 3.665. And we can look at all the choices. The closest we can get from this calculation is this answer. All right, that provided the boundary value or the GPA that we require to be in the top 10%.